Hello and welcome to Anne's Maths Club. Here we love mathematics. Welcome back. It's an honor to have you back with us here ready to study mathematics. Remember here our slogan is I love mathematics. So I want you to repeat after me wherever you are. Just say I love mathematics. So let's get to class. Welcome here. My name is Mwalimu Anne. And today I'll be guiding you into a very interesting topic. We're going to be introducing Surds. So basically, we're going to talk all about Surds. From the order of Surds, we're going to go deeper into simplification of Surds. And also we're going to go step by step into what are the key concepts and how we can be able to work on them. Let's get to it. Amazing. So we're going to begin with Surds. As you can see, I've written it as Surds. And this applies both for the 844 curriculum. We have the IGCSE, so it's basically the working is the same. So let's get to it. So when we talk about Surds, basically these are numbers which have got no square root or the cube root. For example, we don't have the root of 2, okay? We also don't have the root of 8. So such numbers are what we call Surds because they have no square root or cube root. And I know earlier you taught about square roots or cube roots, but in case you want me to dig deeper into that, please let me know at the chat. So when we talk about this, so this is just an introduction. So I'm going to be taking you next into the order of Surds. So for example, we have the root of 2 and the root of 8. So these are of order 2. And why do we say order 2? Because it's the square root of 2, square root of 8. If it was the cube root, maybe, we'll just use the same number, we can say 3, or cube root of 2, or so for the such. We can say these are of order 3, okay? And so forth. So when you talk about the order depends on the root. If it's a square root, 2. Cube root, 3. Fourth root, and so forth. So for an instance where it's for the fourth root, we say it's of order 4. So I hope up to there we are all on the same page. So next, I want us to look at simplification of Surds. So remember, I've taken it step by step, so you have to watch out so that you can get it clearer. So when you talk about simplification of Surds, for example, you've been asked to find the square root of 12. And basically, the square root of 12, we don't have a square root for 12, but we can simplify it. You can come here and take 12, okay? And therefore, you can be able to work it out as a tree. I'll use a tree diagram. So you can start with the simplest number, which is 2. How many times you add 2 to 6? That is basically, to 12. That is 6. And then this 2 times 3 will give you 6. So basically, with a tree diagram, you start with 2. Basically, 2 times 6 is what will give you 12. Then here we have 6. 6 will be 2 times 3. It's also 2 can also go through by 6. So we'll come here and now extend it to be 2 times 2 times 3. So instead of writing it as 12, we write it as 2 times 2 times 3. You take these values outside. And basically, what do we mean? So when you take 2 times 2 times 3, it basically is the same as 12 because 2 times 2 is 4, 4 times 3 is 12. So you can now come and write it in terms of a square. So 2 times 2 can be written as 2 to the power 2 times 3. So what happens? Remember earlier when we talk about indices, there is this rule that you need to observe. The root of, if you have a to power 2, a squared, and you're asked to find the square root, this basically is the same as cancelling out the square root with the 2, and you are left with a as your answer. So basically for this case again, you can come and separate them. Have root of 2 squared times root of 3. So write them separately, then this square root will cancel with the this square will cancel with the square root and you're left with 2 as a whole number. Then because we don't have a root of 3, you're left with root of 3. So your answer becomes 2 root of 3. So basically this is simplification. So allow me to take you back again. So when we are simplifying surds, you get here we have the root of 12. So we have to simplify it so as we can get an answer that is a simplified surd. So what do? We can use the tree diagram and we start with the 12 by 2, that will be 2 times 6, so that you get 12. At 6, 2 times 3 will give you 6. Then you leave it at that, basically, the factors. So you come and write the factors, 2 times 2 times 3. Then basically now, for 2 times 2 is the same as 2 to the power 2. Because it's 2 times. So that is 2 to the power 2 times 3. Then you come and separate them, each of them to have their square root sign. You separate them outside, so that this becomes 2 to the power 2 times root of 3. Then, like I said, you use this rule. You need to have this rule with you. Anytime you have a square and you've been told to find the square root of that number, the square will cancel the square root and you're left with a. So then you're therefore left with 2 times root of 3. So if you're asked to simplify the root of 12, your answer becomes 2 root 3. So that is simplification. I'll do another example, then we can proceed. Amazing. So looking at example 2, when we focus on simplification of surds. So like I said, you take the 72 and you can use the tree diagram to solve it. So always start with 2, the factors. So you can start with 2. 2 will basically go to, by 72 divided by 2, you get that 6. Again, 2 is also a factor of that. So 2 will go 18. By 2 we get 9. Then 9 is a factor of 3 by 3. So basically, you have 2 times 2 times 2 times 3 times 3. So 72, we can write it as 2 times 2 times 2 times 3 times 3. Then remember this formula that we talked about. A squared, the square root of that, these 2 will cancel out and you're left with a. And remember, because it's a square root, so we can place them in, raised to power 2. So this is 2 times 2. You can take this 2 and write them as 2 to power 2. Then for 2 is left like that because we don't have another 2. Then 3 by 3, 3 to power 2. Then you're able now to find the root. Okay? Then the next step, you come and separate them. So you have square root of 2 squared times square root of 2 times the square root of 3 squared. So these 2 and this 2 cancels out. The square and the square root cancels out. You're left with 2 times. We don't have, this is a surd. Remember we said surds do not have, they don't have the exact square root. So that remains as root of 2. Then this and this cancels out and you're left with times 3. So once you get here, you take the whole numbers, that is basically 2 times 3, and then you multiply with the surd 2. So that is 2 times 3 is 6 root of 2. So when you're asked to simplify 72, basically you can write it as 6 root of 2. So basically when you talk about simplification, I would advise this tree method is basically easier because then you get to put them in their factors and then now you place them to powers of 2. And for those that don't have the powers, you can leave them as such. And then now you come and separate them, then collect the whole numbers, multiply them, 2 times 3 is 6, and the root of 2. So this is how you simplify surds. So let us proceed to addition and subtraction of surds. So let us look at addition and subtraction of surds. Remember, we're going step by step for you to understand better. And remember, the main key thing with mathematics is the accuracy. So as long as you've gotten the concept clearly, you can then be able to calculate the question well. So what do we mean when we talk about addition and subtraction of surds? So basically, when you talk about addition and subtraction of surds, it means you can only add or subtract when the values are the same under the root sign. For example, if you have root of a plus root of a, remember here you look at the values under the root sign. So the values a and a are the same. So you can only add or subtract when they are like surds. Basically meaning the value under the root sign is the same. For example, root of a plus root of a. What that means, if I was to give you two mangoes, yeah? So I have one mango, I use M to represent a mango, plus I add another one mango. So mango is constant, but then they are 1 plus 1, 2 mangoes. It's the same as this. So it's like, so this represents there's like a constant 1 in front and there's a constant 1 in front. So 1 plus 1 is 2, then they're similar root of a. So basically I want you to think of surds in that aspect. For example, I'm going to give you an example with numbers. So we have root of 2 plus 3 root of 2. So remember what we said. You can only add or subtract surds when the number under the root sign is the same. So this is the number under the root sign is 2. The number here under the root sign is 2. Good. So you always assume there's an imaginary one here. So that is 1. So what you do, you add the numbers that are outside. So that is 1 plus 3, then root of 2. So that becomes 4 root of 2. I hope that is very clear. For example, when we go to subtraction, you have maybe 8 root of 5, okay, minus 3 root of 5. Basically what that means, you take the external 8 minus 3, so that becomes 5, but because both of them have the same number under the root sign, so it becomes 5 root of 5. So what it means when it comes to addition and subtraction, you can only add or subtract if the number under the root sign is the same. So for this case, we can go ahead because it's root of 5, root of 5. Then we can work out the numbers that are outside. For this case, root of 2, 2, so we can work out. For example, if you had a long question, maybe root of 2 plus 3 root of 5 plus 4 root of 2. So what it means here, this is a different example, kindly note. We have we can talk about collecting like terms. For us to go ahead and add, we'll collect those that have the same number under the root sign. So we'll take root of 2 plus, this one has root of 2 as well, so plus 4 root of 2 plus 3 root of 5. Because this one is not the same. So we can go ahead and work this out. So this is 1 plus 4, it becomes 5 root of 2, then you come and add 3 root of 5. So this becomes your answer. So basically it's that simple. When you're adding or subtracting surds, I urge you please, you can only do that if the number under the root sign is the same. Then you work out whatever is outside. The other key thing, always if you're not given a one outside, remember there's an imaginary one. Here there was an imaginary one. Go ahead and work it out as 1. So this is addition and subtraction of surds. So let's move on to the next section. Amazing. So we're going step by step into surds. If you're watching this video for the first time, I urge you to go back and watch our previous videos. We've talked about addition and subtraction of surds. We've talked about multiplication and division. We went ahead and guided the students into simplification. And now we're going on to rationalization. So let us get into it. So when you're given 1 over the square root of 7, so basically when it comes to rationalization, what basically it means, you take the denominator. So I'll go ahead and introduce, this is usually your numerator. When you talk about fractions, the bottom is the denominator. Okay. So what it basically means, you take 1 over root of 7, then you multiply, when you rationalize it, you multiply the denominator on both sides, up and down. So that is step number 1. So then we proceed. So you come and multiply the numerator, then you work out the denominator. I will advise you, so as to avoid careless mistakes, you can do them separately. So I can take the numerators, that is, so I'll write it as known to represent numerator 1 times root of 7, okay? So remember we talked about with multiplication, the values, you can multiply the values as they are. The other key thing I think I didn't mention is, remember, before the 7, there is always like a 1 here. So you get to multiply the whole numbers together, then whatever is inside, inside the root side, you multiply it as well. So you take 1 times 1, that is 1 root of 7. So this basically remains as root of 7. Okay, because the 1 is the whole number and the 1, like we said, is an imaginary 1, so that gives you 1 root of 7, which is basically any number by 1 is that number. Then we work out the denominator, and that becomes root of 7 times root of 7, and this becomes 7 root of 7. Remember for multiplication I said you combine 7 times 7, that becomes root of 49, but remember the square root of 49 is 7. Okay, it's the same as I would have said it here as root of 7, because it's 2 times 7 squared. Then we say the square will cancel with the square root, so your answer is still 7. Okay, so the denominator is 7. So you come and combine, the numerator is root of 7, denominator is 7. So that becomes your solution. So this is the first section when it comes to rationalization of surds. Like I said, you take the denominator, multiply it on both sides. Okay, then you take the numerator, multiply 1 times root of 7, you get root 7, denominator root of 7 times root of 7, and you get your answer as 7, and this becomes your solution. So let me get you further into rationalization of surds. Welcome back to Anne's Maths Club, and today we focus on multiplication and division of surds. So when you talk about multiplication and division of surds, basically what you need to do is multiply the values, multiply or divide the values under the root sign. For example, we have root of A times the root sign of B. So you come and take the numbers under, and remember the difference is with addition and subtraction, they have to be the same numbers. So remember for addition, you would have only worked it out if this was A and A, or it was B and B, if the numbers were the same. But for this case, they are not the same. So you come ahead and take it up and say A times B, so this becomes A, B. So you multiply the two values and you get your answer as A, B. For example, if you have 2 times root of 3, you come and multiply the 2, the root sign of 2 times 3, and you get your answer as root sign of 6, okay? The side of 6. So the other key thing, for example, if you have values outside, maybe you have 2 root of 5 times 3 root of 6, okay? So what then you go ahead and do, you come and take it as, you take the external of the values outside, so that is 2 times 3, 2 times 3, then the root sign, values under the root sign, 5 times 6. Okay, so you take the 2 times 3, becomes 6, 5 times 6, 30, so that is 6 root of 30. But then you need to think and ask yourself, can we simplify 30? Okay, so you come and take 30, then you go ahead and simplify it by 2, 15, by 3, 5. Then you see these values cannot be simplified further. Remember, for simplification, if it has to be a number that has a square, For example, if this was maybe 2 times 2, then that would have made sense. But in our case, we cannot simplify 30. So we leave our answer as 6 root of 30. For example, if it was a separate question, maybe we have 3 root of 4 times 2 root of 3. So we take 3 times 2, the ones outside, then the root sign of 4 times 3. So this becomes 3 times 2 is 6, then root 12. Remember, ask yourself, can we simplify 12? Never leave your answer without simplification. So 12, you use the 3-factor method by 2, 6, by 2, 3. So you can write 12 as, so it's the same as 6 root of 2 to power 2, because this is 2 times 2 times 3. So you put them aside, so this is 6 root of 2 squared times root of 3. So 2 squared becomes by 2, and this square cancels out the square root sign. So 2 comes outside, and you're left with 6 times 2 root of 3. So this becomes 6 times 2 is 12 root of 3. So your answer, instead of leaving your answer as 6 root of 12, you come and write your answer as 12 root of 3 after simplifying it. I hope that is very clear. Maybe I'll just repeat it. But like I said, you have 3 root 4 times 2 root 3. So you take the values outside first, you handle them separately. So that is 3 times 2. Then the root sign of 4 times 3. So this becomes 3 times 2 is 6. Root sign 4 times 3 is 12. Remember, I talked about simplification. If you've not watched our video, go ahead and get to watch it. So 12, 2, because of 6, 2, 3. Then you have to put them in factors. And so this is 2, because 2 times 2, 2 squared times 3. Then you separate them, 6 root of 2 to power 2 times root of 3. Then remember the value that this, you need to have this in mind. Root of a squared will give you an a, because the square will cancel with the square root, always. This is a rule that you need to have in your mind. So you come and work it out like that, and you're left with 6 times 2 root of 3. So this is 6 times 2, 12 root of 3. And this becomes your solution. So this is multiplication. So let me do division, then we can close on this section. So when I talk about division of surds, basically again here, you work on the values aside. So for example, we have root of A divided by the root of B. Like basically the surd of A divided by the surd of B. So what it means with division, you can come and work it out like this. Have this, then this is A over B divided by B, basically. For example, if you have root of 6 divided by root of 3, this becomes 6 over 3, and you're left with the root sign of 2, because by 3, 1, by 3, 2. So basically for division again, the values need not to be the same. Again, if you have maybe 2 root of 6 divided by, I'll just use the same example, but you introduce that 2. So remember, I said there's always an imaginary 1. So this is basically taking it as 2 over 1, then root of 6 over 3. So this is 2 over 1 is 2, and this becomes of 2. So that is your answer. So you take the ones outside, and outside, then you divide the ones inside. I'll take another example. Maybe you have maybe 10 root of 15 divided by 5 root of 3. So again, we take whatever is outside, 10 over 5, then introduce the root sign, whatever is inside, 15 over 3. So this becomes 10 divided by 5, 2, 15 divided by 3, 5. And therefore, your answer becomes 2 root 5. So basically, these are the main key things. So when you're calculating such a question, when you're doing multiplication or division, you have to observe whatever is outside, work it out as a pair, and whatever is inside, under the surd form, under the root sign, go ahead and work on it. Basically, under the root sign, work on it as well, and you will get your answer. So I'll do an example that caters all the different sections, then we can be able to proceed. Amazing. So when we look at difference of two squares, I'll start just taking us through an example, then we can get into how then do we work on surds. For example, if you have a plus b squared, okay, so when you're calculating this, you don't take it, disclaimer, you don't take a, then you square it plus b squared. No, you come and take a plus b times another a plus b. Remember when we talked about square, if you have 2 square, it's the same as writing it as 2 times 2. So it's the same as working this times another version of itself. So then you can now take the first a and you multiply it by everything on this other side, a plus b. Then you take this plus the sign before it, so it's plus b. Then you multiply a plus b. Okay, so then you can go ahead and work it out. A times a is a squared, a times b, ab plus b times a, ba plus positive sign and positive sign. This is where most people make a mistake, because this is a positive sign. You have to multiply it with the sign that is here. Remember, if it was a negative sign, it would have yielded to a minus sign. But a positive and a positive will give you a positive, so b times b is b squared. So your answer becomes a squared plus, you have ab, this is the same as ab, ab is the same, so assume there is 1 before. You can assume, for example, if I talk about mangoes, I give you 1 mango, again another mango. Basically the mangoes are constant, but now there are 2 mangoes, so basically 1 plus 1, you get 2 ab, because it's 2 of them, plus b squared. So this is the logic that you need to use when you're calculating these questions. For example, let us work it out in form of surds. Maybe you have the root of 2 plus root of 3, and you've been asked to find the square. Okay, so you come and take root of 2 plus root of 3. For square, it means 2 of them, just like we did here as well. Root of 2 plus root of 3. Okay? Then you come and take root of 2. Then you multiply it by everything on this side. Root of 2 plus root of 3. Then you take this with a positive sign plus root of 3. Now this, again multiply with everything here. Root of 2 plus root of 3. So this becomes root of 2 times root of 2. Remember when we talked about multiplication, we said it doesn't matter if the values are the same. You can multiply them as they are. If this was a and b, you can multiply them. But the only difference will come in when we are adding or subtracting. So root of 2 times root of 2, basically it means 2 times 2, you get root of 4. Okay, but again, I will guide you next on how to simplify this further. Plus root of 2, you multiply by root of 3, it becomes root of 2 times 3 is 6. Okay, then you continue, root of 3 times root of 2, it becomes 3 times 2 is 6. Then a positive times a positive is a positive. Root of 3 times root of 3 is 3 times 3, you get 9. But remember, the square root of 4 has a square root, it's 2. Basically, even when you work out with the calculator, it's 2. Then, for 6, it doesn't have, it's a surd, it doesn't have a square, it doesn't have the square root for it. So basically, you take this, you can go ahead and add them, because remember we said 1 and 1 outside. As long as the values under the root sign are the same. So this becomes 1 plus 1, it becomes 2 root of 6. Then lastly, we have root of 9, which is 3, because the square root of 9 is 3. So then you collect the like terms, 2 plus 3, whole numbers, plus 2 root 6. This becomes 2 plus 3 is 5, plus 2 root 6. So this becomes your answer. So what did I do? Remember, just recap very quickly. When you see the square, you separate them like that, 2 of them. Then you take this first value, then you multiply by everything on this other side, the same. Then you do the same to this side and multiply by everything. Then square root of 2 times the square root of 2 will be there. You multiply whatever is inside, 4 plus 3 times 2 is 6, 3 times 2 is 6, 3 times 3 is 9. Then the square root of 4 is 2, the square root of 9 is 3. Then for these two values, you can go ahead and add them and get 2 root 6. Then collect the like terms, 2 plus 3, then you add 2 root 6, you get 5 plus 2 root 6. So basically this is one of the examples, and I'll be doing another example. Moving on to example 2, remember we are still focusing on the difference of two squares. So we have 2 minus root of 3, 2 plus root of 3. So like we said earlier, you take this first value 2 and you multiply by everything on this other side. So that becomes 2, you multiply by 2 plus root of 3. Okay, then you take this next value, and remember when you're taking it, you carry to the side negative root of 3. Again, you multiply it with everything here. So you multiply it with 2 plus root of 3. So this becomes 2 times 2, you open the bracket, 4 plus 2 times root of 3. Remember, in such a case, 2 is a whole number and this one is under the root sign. So you take 2, basically before it we have a 1. 2 times 1 is 2 root of 3. Okay, then this is a negative sign. Root 3 times 2, again it becomes 2 root of 3. Then negative sign and positive sign is a negative sign. Root 3 times root 3, you get root of 9. Okay, then we go ahead and simplify it further. This becomes 4. And then you have plus 2 root 3 minus 2 root 3. Remember when we talked about addition and subtraction, we said you can only add or subtract if the number under the root sign is the same. So this is 3 and this is 3, so we can go ahead and work on it. So 2 minus 2 is 0. So this cancels out. Then you are left with 4 minus root of 9 is 3. Okay, then you get 4 minus 3, 1. So your answer becomes 1. I hope that is clear. So basically that is how we work on. Like we said earlier, you take the 2 multiplied by everything, then take the negative root 3 multiplied by everything. The main key things to observe here is the root sign. If it's a negative, ensure you put it in place and then you work it out as well. So let's proceed and see how to further calculate questions in this section. Amazing! Now that we've talked about rationalization and I urge you to look at our previous video, I'll take you through how then do you tackle such questions, okay? So basically what happens, like I said earlier, when it comes to rationalization, you take the denominator and you multiply it both on the numerator and denominator. But the main key thing here is you take the denominator, and you change the sign. For example, this is root of 2 plus root of 3 over root of 6 minus root of 3. So you come here and multiply with this denominator, but you change the sign, it becomes root of 6 plus root of 3 over root of 6 plus root of 3. Whatever you do in the numerator, you do in the denominator. So basically what it means, you take the conjugate, which is basically this, you change the sign, conjugate, that is what we mean. So once you've gotten it to be such, this is step 1. Okay, so when we go to step 2, I would urge you to work on the numerator. So on the numerator you have root 2 plus root 3 multiplied by root of 6 plus root of 3. So work that separate. So this becomes root of 2. Remember, I have taught you in our previous videos how to multiply such. You take root of 2, you multiply by this side, root of 6 plus root of 3. Then you add this root of 3, multiply again with everything on this side, root of 6 plus root of 3. So this becomes 2 times 6 is root of 12 plus 2 times 3, root of 6 plus, this is 6, 3 times 6, root of 18 plus root 3 times 3 is root of 9, which technically is the same as 3 because there is the value for the root of 9. So once you arrive here, remember I taught you about simplification of surds. Remember, for 12 is the same as writing it as 4 times 3, and the root of 4, the square root of 4 is 2, so it becomes 2 root 3 plus root 6 plus 18 can be written as root of 18 is the same as 9 times 2, then that becomes so plus root 6 plus root of 9 is 3, root of 2 remains as such, plus root of 3. Okay? So we have up to this far. So you can come and write them well. I'll write it as 2 root 3 plus, I've gone ahead to simplify. Remember I said it's important not to leave your answer as such, so you need to simplify. Plus 3 root 2 plus root 3. Then you go ahead and collect the like terms. Like terms are those when we are adding or subtracting, the value needs to be the same under the root side. So it becomes 2 root 3 plus root 3, because root 3, root 3 they are the same, then plus this other side, root 6 plus 3 root 2. So remember, for addition, because the values are the same, you can go ahead and add. This is 2 plus 1. Remember, we have an imaginary one when you're not given. That becomes 3 root 3 plus root 6 plus 3 root 2. So this becomes your answer. You can no longer add further or subtract because the values under the root side are not the same. So basically, I hope this is very clear. Like I said, the first thing you find the conjugate, which is this value, you just make the sign, it becomes a plus sign, then multiply the numerator, then that is what we have done. So this becomes our solution for the numerator. Remember, step 2, we need to work on the denominator. So we have another step. So let us go ahead and find the denominator. So I'll have to wrap this and we can continue with finding the denominator. So let me put the answer for the numerator so that we can now find the denominator. So numerator, we found it as 3 root 3 plus root 6 plus 3 root 2. So let us go ahead and find the denominator's value. So step 3, under the same question, we now handle the denominator. So this was the numerator. I'll actually write nu, and we've gotten the answer, and then denominator. So this becomes root 6 multiplied by root of 6 plus root of 3 minus root 3 multiplied by root of 6 plus root of 3. So this becomes root of 6 times root of 6. Basically, it's 6 times 6 is 36. And the root of 36 is 6. The square root is 36. So you can leave it as such. Plus root of 6 times root of 3 is 6 times 3. You get root of 18 minus 3 times 6 again is root of 18. Remember, when you're expanding, you multiply. Then negative sign and a positive sign gives you a negative sign. We have that topic on that section. So if you find it as a challenge, please go back and revisit. Then we have root 3 again it becomes 3 because 3 times 3 is 9, so the square root of 9 is 3. So that we don't leave it as a sign, because it has the square root in itself. So basically, you now collect the right terms. You take the whole number 6, you subtract 3, and then plus root of 18 minus root of 18. So basically, this is 6 plus root of 18 minus root of 18 minus 3. You go ahead and collect the right terms. 6 minus 3 plus root of 18 minus root of 18. So 6 minus 3 is 2. Sorry, 6 minus 3 is 3. Is 3, sorry. Is 3. So, and then there is an imaginary one here and an imaginary one. So remember, we said for addition and subtraction, you can add or subtract if the values under the root sign are the same. So we have 18 and 18. So we take 1 minus 1 is 0. So technically this cancels out. So you have 3. So your answer will be the numerator over the denominator, which was 3. So that becomes your answer. So basically, like we said, step 1, conjugate, addition, change the sign. Step 2, work on the numerator. Step 3, work on the denominator. Then put your answer as such. Remember to simplify. And while we started with teaching you about multiplication, division, addition, and subtraction, is because you need that prior knowledge for you to calculate this side. So let's proceed with the surds topic.